Bagi Bayaw. Today I'm going to show how to solve a problem in Thermodynamics Chapter 3, the ideal gas. So here's the problem. You can see this problem from the book of Unit A, Single, page 156, problem 3-74E. The air in an automobile tire with a volume of 0.53 cubic feet is at 90 Fahrenheit and 20 psi. Determine the amount of air that must be added to raise the pressure to the recommended value of 30 psi. Assume the atmospheric pressure to be 14.6 psi and the temperature and the volume to remain constant. So we are looking for the amount of air. Our given is P gauge 1 is equal to 20 psi and pressure gauge 2 is equal to 30 psi. Our volume is 0.53 cubic feet and the pressure atmospheric is 14.6. So our gas constant, which is R from air, is equal to 0.3704 psi times cubic feet per pound. So the equation that we're going to use is the pressure, which is pressure is equal to P gauge plus P atmospheric. First, we're going to find the pressure 1. Pressure 1 is equal to P gauge 1 plus P atmospheric. So our P gauge 1 is 20 and P atmospheric is 14.6. So 20 plus 14.6 is equal to 34.6 psi. Our pressure 2, which is equal to P gauge 2 plus P atmospheric, is equal to 30 plus 14.6 is equal to 44.6 psi. So after that, we're going to find the mass of every pressure 1 and pressure 2. So our mass 1 is equal to 0.0900 pound and mass 2 is equal to 0.1160 pound. I'm going to show how we come up to this value. Since our topic is talk about ideal gas, we're going to use the ideal gas equation to get the mass 1 and mass 2. So the equation for ideal gas is PV-mRT. We're going to derive this equation by dividing both sides by RT and cancel. So our equation for ideal gas is M mass is equal to PV over RT. So we're going to use this equation to get mass 1 and mass 2. So the value of pressure 1 is 34.6 and our volume is 0.53 and our gas constant of air is 0.3704 times our temperature, which is 90, and our unit is English, so 90 plus 460 is 550 Rankine. First, we're going to cancel the unit, so we have psi, cubic feet, the Rankine, so we already left by pound. So our mass 1 is equal to 0.0900 pound. So after that, we're going to solve for mass 2. Our pressure 2 is 44.6 psi and our volume is 0.53 cubic feet and our gas constant of air is 0.3704 times the temperature, which is 550 Rankine. After that, we're going to cancel the unit, psi, cubic feet, the Rankine. So our mass 2 is equal to 0.1160 pound. Since I already showed how we get the mass 1 and mass 2, we're going to find the amount of air using the equation of change in mass is equal to mass 2 minus mass 1. So 0.1160 pound minus 0.0900 pound, our mass amount of air is 0.0260 pound. Thank you for listening and have a great day, everyone.